One type of question that you're going to encounter on your MCAS exam is these questions that ask for the best estimate or the closest. Okay. Now, why do they do that? Well, because these particular problems are on session 1, where there is no calculator. Okay. So they say best estimate or closest because you'll notice they actually round the answers. Okay, so what does this mean? Well, it means that we can round the numbers in the question, so it's a little bit easier to work with. Okay, so if we read this question, we have Sylvia is planning to use a 4-year loan to purchase a car. So the purchase of the car is $8,575. And the amount of interest she will pay on that loan is $1,036. Sylvia will combine the price of the car and the amount of interest to determine how much she must repay. And she will make 48 equal monthly payments. So which of the following is the best estimate of each monthly payment? Okay, so we need to go back. I want to reread this again. So we have the price of the car is $8,575. And the amount of interest she will have to pay on the loan is $1,036. Okay, so those are our two numbers. And she will combine the price of the car and the interest to determine how much she must repay. All right, so now adding, we don't necessarily have to make any changes. Or, we could round our answers, our numbers here. But let's add them together and see what we get. Okay, so this is the price of the car, and this is the interest. So when we combine them, we're adding them. So 5 plus 6 is 11. 7 plus 3 is 10. Plus 1 is 11. 5 plus 1 is 6. And 8 plus 1 is 9. So she'll pay a total of $9,611. Now, she's gonna make 48 equal payments. So the question is what is the best estimate for each monthly payment? Okay, so this is the total, 9,611. You'll notice if we can round this to 9,600. Okay, now why would I want to round? Well, for starters, working with zeros is easier. Okay, and we're only off by 11. Okay, so we're making things easier, and we're really not changing the value that much. And it's also going to be easier to divide. So 48 into 9,600. Okay. So let's first So when we divide, we're looking for a number that, when we multiply it by 48, we get something close to 96. So I'm going to do 48 times 2 to see how much that comes out to be. 2 times 8 is 6, carry the 1. 2 times 4 is 8 plus 1 is 96. Oh, well, there you go. It's 2. 2 times 48 is 96. And the beauty of changing, rounding to 9600, we just fill the zeros in. So my answer is B. $200, approximately $200 a month over 48 months will give you your monthly payment, okay? So the idea here is that anytime we multiply by 0, anytime we divide by 0, it's just 0. So instead of trying to find, we know 48 can't go into 11. So we would just be putting zeros there anyway. So when we multiply by zeros, when we divide by zeros, they're just 0. So the idea behind rounding, anytime we see best estimate or closest, we are making our mathematics a little bit easier because we do not have a calculator for session 1. Okay, so let's take a look at this next one. Okay, here we have a candidate received 59% of the votes in the election. And in the election, 76% of the 39,881 registered voters cast a vote. Which of the following is closest to the total number of people who casted a vote in the election? Okay, so if you notice, I definitely want to do some rounding here. So 59, okay, I can round that to 60. Nice even whole number. 8 nice zeros. It's really nice. So the candidate received 59%. In the election, 76% of the voters voted. So which of the following is closest to the total number of people who cast a vote for the candidate? Now, it says the candidate received 59%, which we're going to round to 60. So this is actually a two-part problem here. Now 76%, I would probably round that to, I'd make that 75% because it's closest, but 76 is closer to 80 as it is to 70, so let me make this 80%. Okay, and this 39,881, I would round that to 40,000. Okay, so now when we go to multiply, it's going to make our numbers much, much nicer. Okay, so first we need to decode the fact that 59%, which we changed to 60, of the vote, the candidate received 60%. So this is what the candidate received. Okay. And the 76%, which we rounded to 80, of the rounded 40,000 voters actually casted a vote. All right, so this is the total number who voted, and this 40,000 represents registered voters, means people eligible to vote. I can't spell, sorry. Okay, so first thing we want to do is we first have to determine how many people actually voted. So I'm going to take my 40,000 and multiply it times my 80%. Now, first thing we have to remember is that I have to convert my percent to a decimal. Okay, and by doing that, 80% just becomes 0.80 or 0.8. Let's stick with 0.80, okay? Because when we multiply by 100, we move the decimal place 2 decimal points to the left. To convert a percent to a decimal, we have to move 2 decimal places to the left. So that means I'm going to do 40,000 times 0.80. Now, obviously, all of these zeros times 0 equals 0. Okay, so what I'm really doing is just multiplying 4 times 8, which happens to be 32. Now, of course, that's not my final answer, because what I have to do is I have to put all of these zeros at the end of my problem. So I have 1, 2, 3, 4, 5. I got 5 zeros. 1, 2, 3, 4, 5 zeros. But I also have 2 places behind the decimal point. So that means I have to have 2 decimal places in my answer. So that means that 80% of 4,000 is 32,000. Okay, so that represents the total number of people who voted. Okay, so now we can determine the total number of people who voted for the specific candidate, which we rounded to 60%. So we're going to do the same thing again. I'm going to take my 32,000 people, and I'm going to multiply it by 0.60, okay, which is, with all my zeros, is just I'm multiplying 32 times 6. So 6 times 2 is 12. 6 times 3 is 18, plus 1 is 19. So my answer is 192, but then I have to add, I got 1, 2, 3, I have 4 zeros here. But again, I have 2 places behind the decimal point. So 2 of those zeros are behind the decimal point. So my final answer is 19,200. Okay, so which one comes the closest? Well, the closest number to 19,000 is actually 18,000. Sorry. This problem here, we have a rectangular garden, which is 16 1/4 feet wide and 11 3/4 feet long, will be covered with soil. If a bag of soil covers an area of 20 square feet, which of the following is the closest to the number of bags of soil needed to cover the garden? Okay, so first thing we need to do is find the area. Now, nobody likes to multiply fractions, all right? So let's round, okay? So I know that 16 1/4 is the same as 16.25. So I would round that to 16, round nearest whole number. And 11 3/4 is the same as 11.75, which I would round that to 12, okay? Again, we're just looking for the closest, so that's what allows me to round my numbers. So from here, this is the rectangular garden. All right, so let's draw a picture. Okay, rectangular garden. I have 16 feet wide and 12 feet long. All right, and we're going to cover this area with soil. So when we find, so the area of a rectangle is 16 times 12. Okay. 2 times 6 is 12. 2 times 1 is 2 plus 1 is 3. And then 1 times 6 is 6. 1 times 1 is 1. You probably did not learn how to multiply by this like this, and that's okay. That's how I learned how to do it. You multiply any way you need to. But 16 times 12 is 193 feet squared. Okay, so that's my area. Now, it says here a bag of soil covers 20 square feet. And we want to know the number of bags. Okay, so if the area I need to cover is 193 feet, how many bags of soil will I need? Well, each bag covers 20. Okay, so 2, 4, 6, 8, 10. So 5 bags is 100 feet. So obviously another 5 bags would give me another 100 feet, square feet I should say. And so that's how much I need. I need at least 200 cover. So if I have soil enough for 200 square feet, it'll definitely cover my 193 square feet with a little left over. And 5 plus 5 is 10. Oops, sorry.